Hey everybody, my name is Angela Godwin and this is Water Talk brought to you by Water Online. Joining me today, my guest is Scott Bindner. He is with Trojan Technologies. Thank you so much for joining us, Scott. We appreciate it.
No, thank you very much for having me.
Yeah, so I want to talk to you first of all about UV oxidation, advanced oxidation. So what is this and what is it used for?
Sure, no, thank you for the question. So, in normal UV applications, we use UV light in a low dose, low intensity setting to treat for microorganisms such as species of bacteria, protozoa, viruses, and things of that nature. In UV advanced oxidation, or what we refer to generally as UV AOP, we are taking UV light and we're applying it in a more high intensity situation with higher UV doses in an effort to treat molecular contaminants or contaminants of concern. And we do that by taking UV light and adding a oxidant known as hydrogen peroxide to the water. And what happens is that UV light splits that hydrogen peroxide into what we refer to as free radicals. These radicals are very unstable. When they're in the water, they really don't want to be there. And what they do is they react with anything they can find that they can oxidize or steal electrons from. Preferably the contaminant of concern that we want to treat with the UV AOP. And once they do that, they steal those electrons, and that destabilizes the chemical bonds of the molecule, resulting in its breakdown.
It sounds like there's a lot of different contaminants that you could possibly treat for. What are some of the ones that you focus on?
That's anything that has an oxidation potential or can be broken down even directly by UV light are contaminants that we can treat. So historically, we have treated taste and odor causing compounds such as MIB and geosmin in drinking water. But more commonly these days, one molecule that we are treating most frequently is a molecule known as 1,4-dioxane.
I have been hearing about this a lot too. It's in the news quite frequently. So tell me a little bit about 1,4-dioxane. What is it? What are its? Why is it harmful, and so forth?
So it's harmful because it is considered by the United States Environmental Protection Agency to be a probable human carcinogen. And one thing about it, its chemical properties make it very difficult to get out of water once it's in the water. It's a very small molecule, has a very low molecular weight. It is also very soluble in the water. So really, once it gets in there, it really doesn't want to get out.
So how many sites do you have out there that are using UV AOP to treat 1,4-dioxane?
Sure. So we have been involved with selling commercial UV AOP systems for now about 20 years. And over that time, we have sold over 100 full-scale UV AOP installations that are targeting the 1,4-dioxane molecule. And when you add all of those sites together, the total amount of water that can be treated from those sites totals a little over 330 million gallons of water a day, or roughly about 1,200 million liters of water per day.
Wow, that's a lot.
Yeah,
That's a lot.
it's a lot of great installations out there, and it's been a really great business to be in.
Yeah.
Because we're just helping people clean their water up.
For sure. And so what other types of products have you contributed to these installations?
So with UV AOP, what we would normally provide is a UV chamber. One of the chamber we provide most frequently now is what we refer to as the Trojan UV Flex AOP chamber. Also, these systems are very easy to maintain. All treatment can be, all maintenance can be done from one side of the UV chamber. So all standard maintenance, such as removing the lamps to replace lamp bulbs, removing sleeves to replace sleeves, wiper seals, and any sort of calibration you may need due to the UV sensor. That's all done from one side of the UV chamber. So what that means is the other side of the UV chamber that you really don't need access to, you can install that up against a wall or any other sort of obstruction, and it really makes it easy to install these UV chambers within within a given space.
Sure.
Many of our customers, space is at a premium. They may not have enough room to create new buildings or new infrastructure to accommodate these chambers. So with our technology, we're able to maximize the number of options that our engineering partners and contractor partners have to install these UV chambers.
So that's awesome. So now what about after it's already installed? Is there anything that customers can do to kind of, operate more efficiently or less expensively?
Well, that's actually one of the great points about the system is there really isn't anything the customer necessarily needs to do. It's already sort of programmed into the controls philosophy that we provide with our UV AOP systems. What this controls philosophy is able to do is really find the point of operation that is the lowest cost to the customer. And we realize that this is really a moving target. There isn't a single point of operation that a customer would work at. Electricity costs a certain amount, hydrogen peroxide costs a certain amount. So our system allows the customer to automatically basically identify where the lowest cost point of operation is, and we're able to make adjustments to the system's operation in order to be able to stay at that low cost operation point.
Oh, that's great. That's awesome. Well, listen, Scott, thank you so much for walking us through the process, and we really appreciate it. And if our viewers want to learn a little bit more about UV AOP or Trojan Technologies, where would you send them for some information?
Yes, the easiest thing to do would be to contact us through our website at www.trojantechnologies.com. You can fill out a form on our Contact Us page, give us a little bit of detail about the site that you want to treat, and we can take you through the next steps in the AOP journey. What we would generally recommend is that, if possible, send us a small sample of your water. Our laboratory would analyze it free of charge and determine how easy that water is to treat. And from there, we can proceed to a full-scale design and go from there.
Excellent. Well, terrific. Well, we thank you very much for joining us, and we wish you all the best of luck going forward.
Well, thank you very much for having us. I
Excellent.
had a good time. Enjoy the rest of the show.
Thank you. You too. And for Water Talk, this is Angela Godwin.